Hi, everyone. Welcome and thank you very much for joining us today. We have a very nice presentation lined up for you today. Two application engineers from two different companies. Lucas Chardulo will be presenting on behalf of Exocad, and Adrienne Slevin of 3D Systems will also be talking about her respective product and the integration that we have between both companies, our partnership, and really detail and explain the various indications that we particularly see as popular options for clinical applications. And Adrienne will come with additional information regarding materials, considerations for 3D printers, and so on and so forth. So without further ado, I'll turn this over to Lucas, who will begin our presentation. Just one other thing as far as housekeeping goes, we do have everyone's mics muted for obvious reasons. There's quite a few of us on the presentation. And if you have any questions during the presentation, please feel free to document those by sending a question in to the staff. Tan, who's also joined us today, and myself will be reviewing those chat threads and answering any questions. If we see something that is relevant for the entire group, we'll certainly interrupt Lucas or Adrienne so that we can address that and address it to the entire group. So thank you very much again for joining us, and looking forward to your questions.
All right, thanks, Dave. Yeah, so for the first segment here, I'm going to go over the design workflows for 5 different product types that lend themselves really well to 3D printing and the printing process, and just show you kind of the highlights and a quick overview of the design process here. So the first product type we'll take a look at in the CAD software at the design steps is temporaries for provisional crowns. So the first case we're going to show here, we have our upper and lower intraoral scan loaded in the software. And the wizard step's going to guide us through the design process. So the first thing it's asking us for is simply to click on the teeth that are involved in the case that we're going to assign provisionals for. Software automatically segments out that tooth section and plots margin points around the virtual margin line there. And we just continue and do that for each tooth for the case. So in this case, we're doing provisionals on teeth 7 through 10. Then we go to the next step in the software in the wizard is the freeforming step. So here, the software is going to allow us to use the anatomic tool. So we're just left clicking and dragging on the teeth shape. So we're lengthening a little bit here. And then we can also use the freeform tools. We'll see that in a second. So we have add, remove, and smooth flatten. This will allow us to continue to refine the tooth forms. Pretty good tools for doing some minor adjustments and adjusting our anatomy and tooth forms here. Then we'll go over on the lingual side. We're just adding some material to the marginal ridges where these will be connected later, just to strengthen our connector points. Next step, we optionally can adjust the insertion path for the case and adjust parameters for the thickness of the provisionals and the slope of the sidewalls. So flipping over to underneath, we can see the virtual prep shape here. And then we get to the connector step. So we can either have the default connectors, or we can switch over to this mode and have the teeth connected where they're close and have a direct connect setting there. After the case saves, we're going to go to an optional step here, freeform restorations. This will let us backtrack slightly and do freeform adjustments on the merged restoration. For example, here we're going to use the smoothing tool and adjust our pontic shapes a little bit. We're going to round over those sharp edges, make more of a modified ridge lap pontic shape here. Then also we can go in and make adjustments to anatomy. We're going to add, again, a little more material to the marginal ridges just to make sure we have a nice strong connector in between our units here. So let's continue making adjustments. We click next and then the case saves. So really quick, easy workflow for provisionals. So that's our final shape there, and that is ready for printing or milling at this point. Let's jump into the next indication. So let's take a look at the design process for models, another great 3D printing application. So again, here's our upper and lower intraoral scans. We're going to start off by jumping into expert mode on this case. So this is a good tool. We're going to edit the mesh. Any additional surface that was captured in the scan, we can trim that away pretty quickly here. So we're just circling the area that we want to remove, get rid of some of the palette scan, click delete. And then we can click the wizard button and jump back into the regular workflow here. So we just need to choose a model type. We're going to choose a playlist type with cutout dies. Here we can adjust the overall height of the model. So a 40 millimeter model height, and we can adjust that if we need to.
One of the things I like about, sorry.
Yep, go ahead, Adrian.
One of the things I like about how you guys have formatted that is you can actually choose it to optimize for your particular printer in there as well. So you guys have added quite a few printers, and it'll automatically, you won't have to dial in your settings.
Yeah, good point. So at that screen where we chose the type for the model, we can choose a specific printer option there and have those settings preloaded and preset. Yep, good point. So this case, so we had crowns designed already on here. So the software pulls in our margin information from the previous design steps. Here we can optionally choose an adjacent tooth to be set as a removable die. And then we have a bunch of settings we can adjust for the dies and the model settings. So here we're going to adjust our insertion path of the dies, adjust them all at once by clicking Set from View. And then we're going to jump over to the other settings tab, and this will adjust things like thickness of the walls of the model. We can tell it if it's a solid or a hollow model. We're going to run the calculation here. We can see the dies being generated, and we're going to calculate a hollow model, which is better for 3D printing. We'll use less material. So here we can see the space ditched out around the dies, and then our die ditching below the margin. Flip that over, and we can see access to the die pins. Let me click next, and we'll jump into the same calculation for the opposing scan here. I'm going to click run. It's going to calculate a base shape for the antagonist scan.
One thing too is a lot of times in the clinic you really won't need removable dies, so there is an option where you can just not have them removable if you're just checking the contacts before you're going to seat the crowns, or maybe the contours of your design.
Yeah, yep, good point. Yep, we could not have the dies sectioned out. So we'll go to the next step here. Software is going to ask us if we want to add interface for articulator. This is a really cool articulator attachment here. This has two interlocking sections that will print out as part of your model and kind of removes the need to glue or use a separate articulator on there. Then also we can add ID text on the model, additive or subtractive. We can add anything we type in that box there, we can set up as an ID printed into the model. And there's our final model design here. All right, surgical guides, great application. Let's take a look at the design process for surgical guides. So our starting point here, the planning would have already taken place in Exoplan. So we have our implant position and the guide, the sleeve component already selected from planning. So the guide design starts off with adjusting parameters for the sleeve mount. So right here, we're going to adjust the height a little bit. And then we're going to add the marker on top of the sleeve mount to mark the X angle of the implant interface for reference after this is printed. Next step is blocking out the undercuts and setting up parameters for the underside of the guide. And then we got to plot points on the model and mark the perimeter the outline of the guide itself. So here we're placing points where we want the support sections to extend on the model. Kind of fast forward a little bit. We went around the whole rest of the arch. Then we double click back on the first point to connect that back up. Then we'll click apply and we'll see the software generate that guide surface. Then we can go back in and adjust these points. Just want to make sure there's enough overlap between the support and the guide sleeve for strength there. Then we can add on some optional features here. We're going to set up a seating verification window. So this purple shape you see on the screen, anywhere that overlaps the implant guide, it's going to cut away that material. So we'll have a circular view window there. Then we'll go in and set up a support bar. So we'll set up cross arch support here, just clicking 2 points to place our support bar. Then the last feature we'll add on here is, again, some ID text. So we type in our text box what we want as the ID, and then just click on the guide anywhere, and that will place that ID text on there.
Lucas, do you have to worry about the gap between where the sleeve and the implant or the guide is, or is that all built in for them?
That is built in. So as you say, the space between the sleeve and the implant. So that's set up back in the planning process. We determine the height of the sleeve in there. This step here, this is letting us use anatomic and freeform tools if we need to make any adjustments on the design of the guide here. There's our finished guide product, so that'll be saved as an STL file, and that again is ready for printing here. You can see the sleeve component placed in there in the sleeve mount. Next up, we'll take a look at dentures. So a new feature in the latest Exocad release, when you go into DB and set up a case, we have 6 different manufacturing process combinations set up in here. So here we have 3 highlighted that involve 3D printing. So we can print the base and utilize pre-manufactured card teeth, print the base and the teeth. That workflow allows you to print the teeth singly or bridge them in any combination that you want as bridge sections. So you can print them as a single bridge, or you can split those up into smaller bridge sections to maximize space on your print build plate. Third option here, print the base and mill the teeth. So if you have a material that you prefer to mill teeth out of, you can use that combination as well. And that's set up when we're first defining the order for a denture. So the case we'll take a look at here, this is also a new workflow in the latest release. This is for a single arch denture. Our first step here will be the model analysis. Software guides you through the model analysis process. So we're going to place 3 points on the opposing model scan to set up the occlusal guide plane. Left to right and center points. Software generates our circular occlusal plane. Next up, we're going to place points on molars, set up our molar points. And then points on the premolars. And that's how it helps the software determine where and how to scale the teeth that we choose in a later step here. So this is tooth placement step. Since we're printing the teeth, it's showing only the scalable tooth libraries. So what's really great about the software is it's going to show us which teeth can be scaled and used for the printing process, and it will show some measurements and size information for most of the libraries here. After we choose the library for the case, we go to the tooth adjustment. This is really our tooth setup step. So here we're using a tool called chain mode. Chain mode's really awesome for dentures because it allows us to rotate and scale and make adjustments to the teeth, and then it keeps everything in contact so we don't lose that ideal contact between the teeth. So we're just going around the arch and making adjustments, lowering the teeth slightly, and also you can see that color map on the occlusal surface of the teeth. That's showing us our position in relation to the opposing skin, whether we're sticking through the opposing skin or if we're too far away, if there's no color on there. So a really useful tool for helping us guide our adjustments here. Now we're going to jump into expert mode, start the virtual articulator. We're going to use a feature here that lets you choose specific teeth in the tooth setup to guide your articulator movements off of. So this tool brings up a tooth chart, and then we can select, we'll choose 6 through 11. That way when the articulator goes through and calculates the movements, it'll be based off of those anterior teeth. So now we're going back to the wizard mode, freeforming. We're just making some adjustments to the occlusion. We're lowering some high points here that were sticking through the opposing skin quite a bit. Then we're going to go to the adapt step, trim these teeth to the opposing, and that's going to take into account the articulator movements here. Then we can go back to the free tab. Any place where the teeth were adjusted from the virtual articulator, we can go in and smooth and refine that anatomy a little bit. After the tooth setup, we need to set insertion path on the base. So we're just setting that from the view direction here. Now we're plotting a line to outline the perimeter of the denture base. So just clicking and placing points on our model scan. Next, now we're setting up connectors. So back in DB, when we set up the case, we set this up to have 3 bridge sections here. So you can just see the connectors in between those sections. Next step is to characterize the base anatomy if we want to. So here's just showing a technique of adding some more refined anatomy to the denture base. So we're going to add a little bit of material in the root prominence areas. So we have the cursor set pretty small. We're adding some material. Then we'll go back and use a subtractive tool here and remove some more material to better define the roots. Then we'll just go in and smooth and blend it in a little bit. So that's a quick technique overview of how we can characterize the denture base. This step here, this is where the base is going to get adapted to the scan and calculate the individual tooth pockets for the denture teeth. So it's going to maintain minimum thickness of the material and calculate pockets that the printed teeth will fit into. Last indication we'll take a look at here, bite splints. I'm going to pull up our CAD software and we'll go through a live design real quick here. So let's switch over to Dental CAD. So here we have our upper scan. So we're going to design a bite splint on an upper arch here. We've already calculated this step here. So bite splint bottom. This is basically the blockout wax and setting up the underside of the bite splint here. Next step, we'll run the virtual articulator. Let's move our articulator panel over a little bit. So you can see the red color over our upper arch. That's showing the minimum thickness required for the material. I'm going to turn off the articulator for a second here. So now I'm going to adjust the pin opening here. Open the bite so we have enough room for the material. I think I figured 3.8 millimeters should be good for this case before. So now we don't see that red color sticking through our antagonist scan anymore. That means when we go ahead with the splint design, we should have enough clearance for the material here. So now I'll go ahead and run the simulation. So we're just using default values on the articulator here. Obviously these can be changed depending on the articulator that you use and have set up for your case. A few more seconds and the software will save the articulator movements. I can click OK. Go back to our design workflow. So now we'll click next here. Now we need to design the bite splint tops. So again, similar to the surgical guide, we're going to left click and place points on the scan, kind of defining the outline of the splint here. Okay, I'll jump around on the lingual side. All right, a couple more points. Back up to the first one, double click. The software is going to generate based on our settings over here. So we have 2.5 millimeter minimum thickness of the material on the occlusal surface. So there's our splint shape. Then jump over to the posterior tab. This is a great feature that lets us select the posterior section of the splint, then automatically have the software flatten that surface. Go ahead and raise that to 1 millimeter. Click Flatten Posterior Area. See the software raised up and flatten that material in the posterior section. Now we can continue and go next. So now we're in the freeform step. So here we can use a smooth tool. We can kind of refine and smooth the posterior area a little bit here. And then we also in the upper right corner have the articulator panel here. So at any time I can turn on our opposing scan, move this slider, and I can see contact color update in real time as I adjust that slider here to see the occlusal articulator movements. So I'm going to jump over to the Adapt tab. We'll cut intersections. We'll remove material on the guide based on the articulator movements. Jump back over to the Free tab, go to the Smooth tool. I'll go to the Add tool, and I'm going to add some additional material that we can use to create our anterior ramp here. I'm going to build this section out. Even without turning on the opposing scan, I can move through the movements and see where those contact points would be. So then one last time, I'll go to Adapt, cut intersections, and do a last round of smoothing here. And also, at this point, the bite splint hasn't been adapted to the scan. So if I want to extend any area of it, I can continue adding material. So even though I plotted that margin line before, that's still adjustable at this point. So if we want to increase coverage in a certain spot, we can adjust that here without having to go back and adjust the margin. So I'll click Next. This will save in the software. We'll save the STL file that we can use for printing. There's our finished splint shape here. Jump back to PowerPoint. I have one last slide to show you guys. So another feature that is built into all Exocad software is ExoPrint. So this really ties the design software into printers really nicely. So this is a denture example on the left side. So after I finish designing that denture case, there's an action button on the right side I can click on. You can see NextDent 3D Sprint here. Then this information window comes up and it lets us select the parts that we want to send to the printer. It's going to show the material that we have selected when we entered in the case. And then it's going to send the STL file and some information from Exocad to 3D Sprint and load that part with the correct material selected already. So really smooth, seamless integration there. So that's it on the design side. Now we'll pass it over to Adrian, and she can pick up on the material and print side here. All right, so switch presenter. Okay, Adrian, you should be up here.
Okay, perfect. Can you see my screen?
Yeah, you're good to go.
Yep.
Perfect, thank you. So thanks, Lucas, that was great. So a couple things here. As Lucas said, we do have a great integration, and there's a lot of things that come into play when you are going digital. You're probably already digital to a certain extent, but every time you bring something new in-house, it is a little bit of a learning curve, and sometimes it's a big learning curve. So what we've done is we've worked with Exocad and other dental CAD softwares, and we've made sure that we can take as much of that trial and error out of it as possible. So we validated a full workflow from beginning to end to help people go digital, whether it's in their lab or their clinic. So what we have here is I'm just going to cover, like Lucas explained, the agenda, the same thing. I'm going to cover the materials that we have. And one of the things that working with Exocad is awesome. It's every module that they have, we have a material for it. And we've dialed in all of these material settings for Exocad's software. So this way, when you choose anything in Exocad, you have a great starting point already. If you already have Exocad, anything after Matera will have our settings built in. If you have something before that because you haven't upgraded for a while or something, we can always give you those settings to put in. Your Exoprint won't work, so it won't automatically launch our software, but you will already have those settings. If you're thinking about going digital, this is one of the nicest parts of it is anything that you choose in Exocad, this is the prescription that you fill out. You can just go here to your material configuration and choose the correct printer that you're using or the correct material. If you're not a NextDent 5100 user, but you are a NextDent user, so you use your material or the NextDent material in your printer, you can still use these settings for the NextDent. It'll have all the minimum thicknesses in and things like that. So if you do have a 5100, you will have that button, as Lucas explained, and this will automatically put everything in there in the correct material. But I'm going to show you about some of the materials that are more popular that you would start with in your office, and then I'll go through how the printer works itself. So the first thing is you don't have to worry about settings, thankfully, finally. Up until now, you've always had to dial things in. So I'm going to start with some of the more popular materials. So obviously a lot of people start with models as they're getting started. We've got ortho build styles and for perio models. We've got diagnostic, which is really nice because you can actually make your matrix there. Lucas designed some provisionals for you. You can actually save that model. If you don't want to do your shell temps, you can design the model and print it and then just make that matrix over there, over that. And you can even use that prep guide if you want and make that. So we do have different options for like printing that as well if you don't even want to do anything manual. And we obviously have prosthodontic. We've got 3 shades here. And you're looking at about 20 minutes for a short model. And when you're designing your model, you just want to keep that in mind, the height of it. Now for ortho, if you're doing aligners or something like that, you're looking at a 30-minute build for 1 layer of models. We've recently introduced stacking. So if you're going to do a full series or quite a few models, I will show you a software example of this. This looks like a lot of work. This is actually 1 day's worth of work, and you can get 18 to 40 models in 1 build. It really helps because you don't have to keep going and cleaning it and things like that. And in an office, you know, you're probably going to have your assistant run it or something like that. So she doesn't have time to go back every 30 minutes sometimes. So we can do a quick turnaround or, you know, a 2-hour turnaround, something like this. This would take about 2 hours to print. And then so every 2 hours, or it's good for an overnight build as well. We also have Crown and Bridge microfilled hybrid, which is a very popular choice because you can do your long-term temps, the provisionals that Lucas designed. You can do 75 units, which you obviously wouldn't need to do, but on 1 plate in about 15 minutes. So this is also the denture tooth material, and your permanent crown and bridges, it's a little bit soft, so I'd say long-term temporary would be good. It's not soft, but it's more like a PMMA type long-term temporary. So, and then we have 6 shades for that. And obviously you can use some Gradia and you can characterize it. A lot of people will make like monoblock dentures or your temps here, and you can just brush it a little bit on, or you can just polish it. Like you can see the one down here. And, or you can do your provisional, implant retained provisionals. And Dr. Hartman, to the bottom right here, you can see that he does his custom healing abutments. So there's a lot of different types of indications you can use for this material. Now it is cohesive, so you can bond it or cement it. So basically you're going to print it and then you'll cure it. And you'll use like a composite polishing kit, just like your regular temporizing stuff, and you can polish it or glaze it. And that's the same thing. I'll show you the denture workflow here shortly as well. So it's a really fast way to get, 6 to 10 crowns out, or shell temps or anything like that. By the time you finish prepping, you could have your crowns ready. And there's an OptiGlaze is what we use on these cases, that you can quickly do that instead of polishing. Now for denture printing, I showed you the monoblock. We've got the try-in material, or you can use the CNDMFH. And like Lucas showed you, you can choose all of those in Exocad. You can also print all of these options. So the material that we use is Denture 3D Plus, and you can print the base, and you can use carded teeth and just use your cold cure. You can reline it. You can print both your base and your teeth and use resin for bonding. Or you can mill your teeth and print your base. And again, you can use your cold cure. So for the denture base itself, you have 5 shades to choose from currently. You can do about 2 to 4 arches in 40 to 60 minutes, and that depends on your orientation. And you're looking at about $6 to $8 for a base. Now, once you've got your denture bases printed and your teeth printed, you'll just use a little bit of resin, and you'll put it in the tooth pockets, and then you're going to place your tooth and your arch together, or your arch and your base together, and then you're going to put it in the cure oven for 30 minutes. Now, when you're done, you can use some OptiGlaze, or you can just polish it. It comes out very, very smooth. I'm going to show you why it comes out with such a nice texture out of the NextDent printer in a little while. But there's hardly, you can see on this middle picture here, you can see just a tiny part of that support. That's as small as those things are. You can just snap them right off with your thumb while you're cleaning the prints. So I'll show you that as well. And there's one in the mouth. So for the try-in, you can use 3 different shades, and it's about $4 an arch with the residual resin and the IPA. That's what you're looking at. And you can also do some characterization. So, what we used to do is put a little bit of pink here around the gum and give it more of a lifelike so that the patient accepted it, and it gave them a better idea. You could print too, for $10, and you could make your adjustments and scan that one in and make your denture if you wanted to, based on that design after your adjustments. Surgical guides, obviously something that a lot of people want to make in-house, really fast and accurate out of the printer and the NextDent resin. It's around $1 without the components. And it takes about 25 minutes to do a single level build. The printer will support all of the different styles that you choose to design. And what happens is you print it, and it's like a translucent yellow. And after you print it, you'll clean it, and you'll put your sleeves in, and then you'll post cure it, and it'll turn like this orange color. And then you'll sterilize it, and it'll turn back to this translucent yellow. Now, if you put your sleeves in before you cure, then you'll have a more secure sleeve fit. You won't have to glue them in or anything like that. And then bite splints. Now we use a translucent blue color for our new ortho rigid material. It's stronger than our older material. We've upgraded it basically. We've added a little pigment to it. And we do a 50 micron build in about 25 to 35 minutes for 3. So you can get those out while the patient's still in the chair waiting. And it's around $5. Now again, you can, they come out nice and smooth, but you'll want to give it a good polish. And you can use your hand piece. And if you had a lathe, maybe you have a little lab in your office, you can use your lathe and that'll polish it up super fast. So what does it look like to set up the printer? That's it for the NextDent material itself, the more popular ones that you'll use in the office. But what's it look like to set up and install it? How much of a pain is it, right? Because we've all gone through the troublesome pain of setting up things, right? So what's it going to look like? What's going to happen is you'll get a pallet delivered. And one of the nice things about this pallet is the projector is steel mounted. So it comes and we're able to fully assemble it, calibrate it, and everything before it gets to your door. You'll take off the top of that, And you'll see that the printer is already put together. Everything's there. You just have to put in the filters, and then you plug it in, okay? And this is what your setup could look like, potentially. So if you wanted to have a long table or something like that, you can fit everything within about 4 feet. Some offices have, let me just escape out of this real quick. Some offices have a really nice setup. I just want to show you the other setup here that I have. It's a hidden picture, but it's worth a view. Okay, so some people will do a nice little setup like this. So you can see that the picture on the right, it's on a pedestal. You can wheel it around. You can put it in front of your patients. My dentist has a mill in the waiting room, you know, and it's cool. He lets you start it yourself, but or you can do some. Yes.
We can't see the hidden picture.
Oh, here, let me Can you see my PowerPoint?
PowerPoint's still live. We just can't see the
clinical setup.
Right.
All right. Well, thank you for letting me know. Let me see how to do this here. I'm going to pause my share real quick here. All right. Can you see it now to the left?
Yes.
Okay, cool. Yeah, so you might decide to do something like this where it's part of your technology that you have in your office. The pedestal is totally optional, you know, and if you have something, maybe it's like a wood floor or something and there's a lot of vibration, you might want to use the pedestal because it has some shock absorbing features. But a lot of people, they'll go to IKEA or they'll do something creative like this. So for all of the materials, regardless of the materials that we have coming out, or if you decide to go make dentures now after you've been making splints only in office, you always need the same tools. So you don't have to get anything extra special if you decide to adopt something new into your workflow. You'll use a bottle mixer, and that'll mix that material that's filled. So if you're just doing like surgical guides, you won't need the mixer, but if you're doing crown and bridge and models and filled resins, especially crown and bridge material has like a ceramic in it. So you want to make sure that all the color in the ceramic is fully incorporated so you get that optimal strength. And then of course you have your printer, and you'll use your own ultrasonic and a couple of beakers. And this is what your workflow will look like. You just need 91% alcohol to go into this, and it takes 5 minutes to clean your prints. And then you'll have your cure oven. And I always say, make sure you get this cure oven because we've developed the cure oven and the materials for each other. So that oven will heat up, and it's got 2 different color blue lights, so that'll develop the color. And you know everything's fully cured before you put it into the patient's mouth. So let's talk about nesting. I would like to show you guys live nesting. So I'm going to show you what Lucas just designed to nest for the printer. I think nesting is a huge thing for printing, and it really stinks when you get some new hardware and the software that it comes with stinks, right? It's like hard to use and it's not robust, it crashes, things like that. So one thing that I love about this printer is it is fueled by an industrial like software, but it's really easy to use, but it can handle anything and quickly. So let's go ahead and bring in, let's bring in our models first that Lucas designed. So you'll launch, and if you're not using Exocad to launch this, then you're going to bring these files in. Now, if I started from Exocad, it would pop them right in here. So I'm going to hit printer, and I have a couple of printers in my office. I have 3. And so, by the way, when this webinar, when my presentation is complete, if you want to stick around for a few minutes, and I can show you my actual setup. So if you have any questions, or maybe you have the printer and you have questions about the printer, I can show you how I set everything up and give you tips and tricks and things like that. Or if you're thinking about buying it and you want to see it live, happy to do something after this webinar. So I'm just going to choose my printer, and I'm going to hit next. And I'm going to choose the material. So it has, every time we add a new material or we add new anything, it automatically pops in here, so you don't have to worry about going and finding it. So let's do a model. And we can do gray, peach, or white. It depends on what you feel is the best for your indication. So we'll hit next. And we'll hit next. And I have a couple different build styles in here, but generally you're going to have ortho stacked, orthodontic, prosthodontic, and you'll have a premium here. I just haven't updated my material. So you can do premium. It looks like a poured model. It's slower, but it's really highly accurate and like just looks completely like plaster, like it's poured. It's real smooth. So we're going to do prosthodontic. And I do not have my printer on right now, so let's see. Okay, cool. So we're going to do file and then import. Oh, hold on just a second. I must have clicked a hotkey or something. Can you see my 3D sprint, Dave?
Yeah, Adrian, you're still good.
Okay, great. All right, so we're going to hit file, import, and there's hotkeys for all of this, by the way. So if you're a real digital tech savvy person, we have a whole list. In fact, we've got this little keyboard up on the top right here that'll tell you all the hotkeys. I'm a hotkey person, but it's not good for webinars because then you can't see the mouse. So I'm going to choose my models, and I just bring in everything possible at the same time. And if it doesn't fit, then that's fine too. I can just remove something. And one of my favorite parts about this software is autoplace. So I'm going to hit autoplace, and I'm just going to cram everything in. So I always change this to 0 and 0 because I want it to be as close together as possible. I'm going to allow Z-axis rotation, so it can just bring it and snap it right in to where it needs to be, as close to the plate as possible. Hit set. Okay, so now you can see that we have everything here, and it's all set based on the orientation that Exocad put it out at, and it's going to be 3 millimeters off of the build platform. I liked that fact that it's not straight on the build platform because I'll show you a little video in a little while about why it makes a difference to me. I'm going to use smart support. I'm not going to combine anything, and I'm going to hit create support. Okay, there's just a couple of steps here to setting up a build. So you can see these are very, very fine tip supports, and you don't have to move the supports around. I love it. You don't have to add, you don't have to remove, and you don't have to check slices like you used to have to do. So it's all set up to where anything that needs to be supported is supported. And the software knows like all the overhanging areas. There's only one indication that I actually add extra supports to, and that's a denture base, because it'll print successfully, but I want it to print as accurate as possible. And sometimes even though it'll print super successfully, that doesn't mean that every area isn't supported from the forces. So there's only one indication that I do that for. Okay, and then you'll just add it to your queue. So we're done with our supporting. And if you don't like where something is, you can always, like, let's say that this is tilted. There's no support on the margin line or anything like that, but if there was a support on the margin line, you could easily just go ahead and move that around. So if you wanted to, you could just hit transform and rotate it, okay? And you can even do like a couple of extra options, dynamic collision check, which will tell you if things are touching. And there's a lot of different new features that we've actually done with settings because everybody kind of has their own preference. If you always want it to start you off with a certain material or always want it to automatically place right off the bat, you can easily just go into your settings and change your preferences. So we tried to add as much to make life easier so you're not being redundant all the time. So you're going to add it to your queue and it'll go over to the printer. It takes about 10 seconds. Now my printer is not turned on because I didn't want any background noise close to me while I'm doing this webinar. So I'm going to go ahead and close this and close this job. And I'm not going to save it today. Now let's nest our crown and bridge models that Lucas designed. So I'm going to import, actually, I'm going to change my material. And I'm going to change it to CNB MFH, which is our ceramic filled resin. So if you designed your provisionals or your long-term temps chairside, what does it look like to nest them, right? So we have 6 different shades and we do have a conversion chart. So if you're using Vita Shade Guide, we'll tell you which one to use to get closest. And we'll hit set. Every time I click that, it pauses my screen sharing for some reason. Okay, file and import. And we're gonna do crowns here. Okay, and I also threw a provisional in here because I thought that would be interesting. So you can actually create a bar in here as well, like you saw Lucas do in Exocad. So if you hit create bars, you just click on one side and then the other side, and that'll stabilize it while it's printing, cross arch. And you can see that we made a real nice little tapered edge here. And so this actually just breaks right off, or you can smooth it off, obviously, if it's an area that's really important that you, well, maybe like a thin area like this might break off. So you might just cut it off. So that is applied. And now you can use your auto place again. And like I said, I like to cram everything as close to the edges as possible. Okay, and so it'll basically just put them all in the smallest area possible. So you can see how much you can actually fit in here. You'll hit Smart Support, and you don't need to combine it. And these supports are so fine that they just rub right off right after you take them off the build platform. And again, like I said, I have my setup here. I did print the surgical guides that Lucas designed, and I printed another one as well to show you. So if you want to see that physical removal, I'm happy to demonstrate that after this webinar. And then you'll send this to the printer. Now, let's see how long it would take. So you can do an estimate and see how much material and time it would take, or how much material you need to have in your tray, actually. Okay, so it'll take 27 minutes. So you can have a provisional and 6 crowns or 6 units in 27 minutes, which is pretty darn good. And you'll have to have 24 grams of material in your tray. Now, this is just to have a successful build. It doesn't mean it's going to take that much material. So I'm going to go back to my presentation now, but this is a good idea of how the nesting, actually, I'm not. I'm going to show you stacking real quick. So let's do, if you're an orthodontist, or if you're somebody else who wants to make aligners in-house, or any other type of orthodontic models, and you want to do a lot of them, I think this is a really cool new perk that we just released it yesterday to everyone. So let's grab these files here. So this is called stacking, and what it is it's multi-level printing, but you don't have to support it yourself. You don't have to hollow your models, because a lot of the CAD software puts out solid models, or you might hire somebody to design for you and they send you solid models. And you don't want to use all that material, right? But you want a strong model, so that way when you do your thermoforming, it doesn't break. So what we're going to do is change our material. So this way we have model material here. And we will do white, and we'll do stacked. Okay, so we brought in all of our models, right? Imagine having to do all of this manually. It would drive you crazy. So basically, we're going to hit create stack arches. We're going to hit apply. And so you can see that they're all marked with the number of the series, and they're all solid. So to save material, what we did was we had it hollow everything out, put a lattice structure in here, and this would work with like bite splint models, opposing models, anything like that that doesn't have a removable die right now. This is optimized for ortho model printing. And we wanted it to be strong, so we kept thermoforming until we made sure that we had a very solid model. So we filled the teeth, but we got rid of all of the solid area. We made a nice 1.5 millimeter model wall to save material. And we also put a lattice structure in there. And you'll see that here in a minute. It takes just a second to calculate. For strength and stability as it's printing. So we're able to print almost 8 inches high in this axis. And what it does is we have stabilizer support. And so it will be just as accurate on the very top in any area as it is at the bottom. And there's some actual settings you can change too. Now we did add supports with very, very fine tips here, and they leave no scarring. You remove them right when they come out of the build. Before you even clean them, you just peel them right off. And there's little feet here, so you can stand them right in your oven, right in your cure oven. You can cure all these at the same time. So anything that's attached to a tooth is super fine, so you won't have anything like that. And we filled the inside of the teeth as well, so you can continuously not worry about any distortion during your thermoforming. And you can grind on the teeth too to make undercuts or whatever your indication requires, okay? And so you can see that we have these little notches here. And so these will just snap right apart and when you're done cleaning them. You can clean them all at the same time instead of doing 4 different cleanings. And we have some settings here, so you can even nest these even tighter if you wanted for a quicker build. You can see that this is I think it's an hour and 55 minutes or something. Oh, and I did print this as well, so you guys could see that if you were interested. So an hour and 50 minutes. Okay, and then you'll add that to the queue. So that's just a little preview of that. Now I'm going to go back to my PowerPoint.
Hi, Adrian. We have a quick question here.
Sure.
With all the settings the same, which do you feel is more accurate, hollow models or solid models?
For our printer, hollow models is more accurate. We have optimized our build speed, so this way we can go really fast and pump quickly. So we won't have as many adhesive forces if we use hollow models.
Thank you.
Okay, so how do we start the printer? I'm going to go ahead and turn this on and show you. This is in my office right now. I thought it'd be easier if I just showed you a video of me starting it. So you're going to see that you'll open it up. I don't have the resin tray in there right now. This is how you'll insert your material in your tray. You can leave the tray in there all the time, but this is initially. And you can see those tension arms. I lower that down. Those adjust based on the tension of the membrane. I have my material rolling. I'm going to print models here. So I'll just go ahead and pour that material in. Now initially you roll it for a while, like 2 hours. But after that, once you pour it in the tray, you'll just mix the material when you're ready to print again. It can sit in there for like 2 months. And we give you a little garage too. So if you want to get extra trays, you can. If you don't feel like cleaning, if you're going to print more than one type of material in your office every day, I would say get another tray. If you're going to print a bite splint every week, then just clean the tray out. You can use it for all of your materials. Okay, so I sent the job. You saw me send it to the queue. And what you'll do is you'll say start job and you'll scan your bottle. And then it'll ask you, did you clean your resin tray? Did you fill your resin tray? Did you put a platform in? And is this the right material or something like that? It has a 3 checkbox. And then you start it and you'll walk away and then it starts. So what is the difference between the NextDent printer? So this is what it means for you, what the differences that you'll see with your visual eyes, the differences of the parts that you'll get out of our printer and the parts that you'll get out of others. Now I've used a lot of printers and these are the things that I've noticed. So what I've noticed is that my resin tray never expires. I can use this tray for all of my materials for 1,200 prints. That's well over a year in a regular lab. I also use less waste if I can print what I can print and mill what I have to mill. Okay, I can get a quicker turnaround and I have a low investment. My tray doesn't expire and it doesn't fog up. So that means I can use it until it dies, right? And that doesn't mean it's going to die in a month or every bottle. So it's also recyclable. So if it does bother you that you're throwing away this aluminum part when you're done in a year, then you can recycle this. It means also with that tray, I can get less warping. I can have a 1.5 millimeter model wall. So I use less material and I have more accurate parts because I have less adhesive forces. Now, you can also do like your veneers and things like that. Now, due to the less adhesive forces, I also do not have you cannot get that suction that comes off and then I have less failed prints. So it's more cost effective in the long run for me. I also don't have to put as much material in because it's quite a small tray. So I can actually print down till I have like 20 grams of resin in there. I also noticed a big difference, and I'm going to turn this down, of part removal. So you'll notice that too, right? So this is what you have to do with a lot of trays that are solid, or a lot of build trays. You have to pry everything off. Now you don't have to pry ours off. You just twist them off, okay? So here's, sorry about that. You can hear this little snap, right? You just pull them off and you rub the supports. And this is with every type of part. Okay, and then you'll clean them. And you'll punch your tray, and it takes about, I would say I put my parts into my IPA, and in about a minute and a half, my tray is clean and back in the printer. So a minute and a half, not too bad, with little or no scarring. Now, this is probably what you guys have all seen too, and you're just like, yeah, this is just a necessary evil, right, of 3D printing. We have to have a lot of supports. We actually don't, okay? So ours are really, really fine, and it's because of that special resin tray and the perforated build platform that we use. And you can see that, like, the picture on the bottom right here has a lot of material that you have to use just to secure it to that build platform. This is what it looks like from ours. So we use very few supports, very fine tips. And you just pull these off, rub them off, and then punch the residual off that platform. Also, we have a nice anti-aliasing, which is what our software does, but you're going to notice that there's less pump lines, but there's also, and this isn't pump lines, this is actually, you can see the pixelation, and you won't see that when you look at ours. You won't see those pixels. And you can see also in this one here, let's see if I can zoom in to this. Okay, so if you look at this picture on the right, this is from our printer. You can just take them out and polish them, or you can put some resin on or something to make it polished for your temps. But if you're trying to temporize this one to the right, you would have a lot of cleanup to do, okay? And you can't really polish that, you have to recontour that. So this is one of the things that I noticed these straight away with the printer. And also the texture, right? I printed this for a friend of mine, and I gave him that bridge, and he put it on this model. Terrible surface quality, terrible. And then same with this, right? This one might be fast, but my God, it certainly doesn't represent tissue. So these are some of the things that I've noticed myself from this. And same with pump lines. We were able to reduce that because there's not as much stress. We have nice thin layers. Now, the way we work through support structure is we have great partners, good dental partners, and we support both of you. So if you're looking for a good support system, it's like a dual support system. So you'll work through a reseller. We have 6 in the United States. And then we also have a 1-800 number. We have email. When US closes, we've got our other countries that open up. So it's not like it's lights out overnight. If you're working late, there's still somebody to help you. Also, all of the equipment is made in the United States, the printers are, and the material is made in the Netherlands at our Vertex facility. Now, if you're interested in learning more about how everything works, we have videos, and we also have things you can read about. And then if you buy the printer, you get access to our academy, so you can learn even more about 3D printing technology. But you do have access to this today, so you can go to the info center if you want to see every little part of what it takes to maintain the printer. It's basically dusting the printer is what you have to do in the long run. There's no calibration or anything like that. So this is the website for our user guide, and you can see how to nest, you can see how to stir the resin, you can see how to put the build platform in and clean parts, everything from beginning to end. So what I always say is when you're considering buying a printer for your office, you want to consider certain things for the long run, right? It's not just like, where's the cheapest thing you can buy to get in here? You want to think about the long-term accuracy and reliability of something. And the quality of the material, right? Because you could buy some junk, but then you have to dial in every setting, and you didn't go to print process school for that, and neither did I. So I found something that I liked this printer because it was a validated workflow. I've used a lot of open source everything, and I usually like open everything. But when it comes to 3D printing, It's a nightmare if you're just dumping different materials into a different system and hoping it works. It takes a whole bottle of resin to dial something in, and then that next resin that you get might not even be the same quality. So to me, that is really important. And also, your support and training obviously is completely, hands down, one of the most important things possible because it's a long-term relationship. And then the ease of use, integrated workflows, everything's real push button. I like that. It does go even further though. Our nesting software can actually do a lot more things. So once you get comfortable, kind of like Exocad, it's easy to use, but anything you can think of in your imagination when you're ready to move forward and do off the wall things or very complicated, intricate things, it'll grow with you. Always ask about your reoccurring fees, right? Including the resin trays. Because even though it sounds cheap out of the beginning, like a $60 tray, it might go bad with every bottle of resin. So you're actually adding that to your overhead constantly. And same with the software, right? Make sure you ask about those the recurring fees. So that way you understand what it is and what it's going to take to get your ROI. And then even though you don't need a fast printer right off the bat, when you're ready to do something new, say you bought the printer for models, but you might want to make bite splints later on down the road. Some printers are so slow that you have to buy another printer to be able to do another indication. So even though you don't need to produce a ton of stuff, you probably will want to be able to make at least 1 or 2 more things in your office that day. So with that, if you have any questions, I'm here. If you want to stick around, I'm here as well. But thank you.
I've got another question that came in, Adrian.
Okay.
So do the models need drain holes? And I think this ties back to when you were speaking about that slight offset that you have off of the build tray.
Yeah, exactly. So our build tray actually has holes in it. And so you don't need any drain holes in your models at all. We always have you keep them up off of the build thing. Our automatic placement keeps them off of the tray. You can always print on the tray, but then you'll have the little divots. I always encourage you to just use that offset, but no, you don't need drain holes. Any other questions?
Getting some compliments. Thanks. A great presentation. Thank you. Yeah, please feel free to ask any questions. We'll stick around until we answer all of them. So for those who are leaving, thank you very much for joining us.
Thank you. If you have any questions, feel free to reach out.
Exocad is also on the line still. If you have any questions from earlier in the presentation, we're happy to answer those as well. Also, one indication that we didn't really get into during this presentation, which is definitely applicable to the clinical audience, is our Smile Creator and Smile Design module. Michael Conan provided us with a presentation this morning. That recording will be available on our website here within the next couple of days, if it's not up there already. And that one went into a more in-depth demonstration of just that specific module, but for any clinicians and even lab technicians that might be on the line today, that's certainly worthwhile watching. Definitely opens up some additional service offerings for your clinic or laboratory services.
Well, before we adjourn, if there's anybody that has anything that they'd like to see physically, go ahead and speak up on your on the question box as well.
Adrian, what is the cost for an entry system?
So it's $99 for the printer. So it's 10 grand for the printer, and it's $300 for the mixer, and it's $1,800 for the cure oven. So you're looking at around $13,000 with no recurring fees. Shipped to your door. Some of the resellers I know right now are offering resin discounts, so extended resin discounts. So you buy the system for that, and then you get like 5 or 10% off, depending on who you're talking to. for resins. Any other questions?
Okay, Adrian, can you show the stacked print that you've already created?
Oh yeah, sure. So let me bring my system over here. Now I did take some of them off of the, or I did take them off of the build platform, but I do have the stack sitting here. You can probably see. I'm going to grab some gloves because I haven't cured them yet. So I printed this yesterday. So I actually pulled off some of these supports already, and I do have the surgical guide build. It's still in the printer actually, but I can show you a close-up of these models here. So if you see, I already pulled off these lingual supports. That's the first thing that I do. If you look at the tray, I did another webinar yesterday, so that's why I did this build. But you can see how tall it is, and basically you can pop these off, and so you can see the feet. Okay, and then you'll just pull off. Actually, here's a couple of the supports that I did not pull off. You can just pull those right off, right when you get them out. I like to take all of my supports off right when I pull them out of the printer, so that you can see. So then after you get it cleaned, I just, I'm working in my home office, so I don't have as big of an ultrasonic. So I use these 1,000 milliliter beakers, and I put the models in, and I just fill up the alcohol, and then halfway through, I'll like flip them the other direction. But there's also, if you have the same ultrasonic that I have, I'll use these as well. So I'll just use a Tupperware, and I'll lay my stacks in, and you can put a ton of stacks. So you could actually do 2 builds and just clean them all at the same time. Halfway through, you'll flip them and put them back in the ultrasonic. So this is when I was doing a lot of stacked printing. I would use that. So once you're done with that, just dry it off. Obviously, you'll pull those off. And I just set mine in my cure oven on the base here. I have some ear protectors in here right now. So in the cure oven, it actually has like a table. And so you'll just set all of your stacks on them. And I think you can fit 14 stacks in here. And then when you're done curing, it takes 10 minutes. So you're looking at about 15 minutes before you're ready to start thermoforming. It takes 5 minutes well, it'll be about 20. So 5 minutes for your cleanings, and then air dry them, and then you'll put them in. And then you can just pop them apart. So you can see they just snap apart, and then you can just pull off that thing. So they snap apart real easy. We timed a bunch of them, and it took about 20 seconds to snap everything apart on all of the builds. And you can see the lattice structure. That actually works out okay. Most people just leave that, but if you don't like it, you can just pop that out too. So, and then you can go to your thermoforming. Any other questions regarding anything like that?
No, that's really a great feature. I mean, just the amount of time that saves in having to worry about how close the models are virtually.
Yeah.
I mean, I know you guys put a lot of effort into that development, and it is just a fantastic feature.
And even if you were just thinking about starting the printer 4 times, because you've got 4 levels, right? And so if you go and you start it 4 times, you actually spend that amount of time starting, cleaning, removing. So even just being able to do it at once is really quite nice too. I don't know any printers that I can get for 10 grand that I can print 30 models on one build, Any other questions? Does anybody want to see the surgical guide build or anything like that? Or are we good to go.
Don't see any additional questions coming in.
Sounds good.
We'll give it a second to see if anyone is interested in the surgical guide build. You can raise your hands, I guess, in the it's part of the little chat there. I see a couple maybe. Yeah, go ahead.
Okay, cool. So my office here, I have two figure 4 printers, and then I have my Fab Pro, which I still need to get a little stand for, so you can see the Fab Pro there. So if you're like just looking for an entry level printer that doesn't do all of this fancy stuff and is really not as fast at all, we still have that Fab Pro, and that's an entry level of $2,500. So anyway, here's my build, and when I pull it out of the printer, I actually just set it up like this, and it's kind of nice. Like I said, it has that perforated build platform, so so all the resin can drain down, and you can actually salvage a lot of the resin. I printed the one that I put that support bar on, and Lucas's that he already had the support bar on. Now, usually what I do is I use this cookie sheet here, and I just cover it with foil. I cover it with like 5 pieces every Friday. And every day I peel off one of the pieces, so I don't have to clean my tray all the time. But since I'm walking across over a floor, I want to make sure that I protect everything from the resin. So basically, I'm going to bring that over, and then I've got my mixer as well. So you can see my mixer over here. And I actually use the, let's see, there's the mixer. I use this little drawer thing in case if you guys already have the printer or something like that, but I use this from Walmart. I just put little labels on there, and I keep all my trays in there, but all the trays do come with a garage, right? So you can see that it's here's my resin tray. So I have all my different resins in here, and I just keep them. I think this little drawer thing cost me like $15, but now everything's nice and organized, and I had that at the lab too, so. Okay, so back to the surgical guides. So what you're gonna do here is, now these aren't fragile at all, right? If I was doing veneers, I would actually punch them from the bottom, but that's about the only thing I would do that for. So all you have to do is just pull them off of the tray, and then you just rub off the supports, okay? Okay, so you just rub off the supports. Okay, see? Okay, and then you'll put it in your alcohol bath, and you can use your old alcohol first. Now, if I'm doing like a bleach shade or something, I don't use any old alcohol. I always use new alcohol for both. I don't want to get any color in there from any of the other resins. And so same with this one. Okay, so I'm just going to pull off my supports, and actually, it's like I told you, that support bar just comes right off. That was just for printing. So you just peel off your supports. This is like my favorite part. I've used so many printers, and I've never gotten this type of perk here to be able to just pull off my supports. Okay, so what you're going to do is you're going to put that in for 3 minutes, and then look at my tray. Some of the resins, it just comes right off, so you don't even have to punch them. My resin tray, or my build platform, is already clean. I'm just going to put it in this Tupperware container. We actually give a stand here in case you do need to punch it, and I have a Tupperware here. And then here's the stand, right? So I just put that in there, and we send out a bunch of little tools too. So we send out a punch tool, we send out a little scraper, and we send out a brush, right? And so now if I am doing something that's a fragile part, so I just use this brush. This is all my old IPA, by the way. I use my IPA for like 100 times for all different types of things. But so anyway. So then I just use white balls, and I put them in between my trays, right? So that my trays like dry real quick, and they're ready for the next use. Okay, so that doesn't take long, right? and then after my first bath of 3 minutes, then you put it in a perfectly clean bath. So if you're planning on just doing crowns or something like that, just use a little beaker. So you're not using much IPA at all, right? You'll just cover the parts. Like for these surgical guides, I would have used this beaker here. So I could use as little IPA as possible. And I know IPA is hard to come by right now. I actually bought some from my from the big Costco right before this thing happened, so I have a lot of it. But you can use bioethanol. That's actually part of the FDA. So clearance that we have is bioethanol. So 3 minutes, then 2 minutes, then you're going to blow dry. And if you already use NextDent surgical guide or any other surgical guide, if you do not get that IPA dry or also there and completely evaporated, you will have microfractures. Okay, so make sure no matter what kind of printer you're using or what kind of material, that your IPA is fully evaporated before you post cure it, because you're going to boil it. Okay, if it's a heat cure oven. So just use an air hose and dry it. Put your sleeves in. Put it in here for 10 minutes. We have a chart. And even if you're just using NextDent, but you're not using a NextDent 5100, still use this chart. It's real important. We validated everything with it. And so it'll tell you how to stir, mix, and how long to cure. It's right online. I just printed mine out and taped it to my cure ovens. This way it's easy access. So yeah.
Adrian, request came in. Can you briefly go into maybe the differences between your entry-level offering and the 5100?
Yeah, okay, sure. So the entry-level offering is called the Fab Pro, and it does not have that resin tray that I was talking about, right? It doesn't have the oxygen permeable membrane on it. So you are going to replace your resin tray more often, which is the vat that holds all of the resin. So when I said the Figure 4 technology on my PowerPoint, this is not Figure 4 technology. This is just a DLP printer. It's like a little industrial grade printer. I mean, you saw it. It's pretty. It's a medium size, right? It's like 70 pounds, but it does last longer than your normal entry-level printers at that same cost point. But it's not the same type of technology. It doesn't hold all of the same NextDent materials either. So for something that takes about 25 minutes in the NextDent printer, or 20 minutes, the Fab Pro would take about 2.5 hours for that same. So it's a little slower, or a lot slower. But it's a good option if you're just not ready to spend $13,000. But you will have the bigger supports because it's not using that technology. The build platform is, I think it's solid. Let me see if I've got it. But it is the same size. Well, anyway, I don't have it handy, but the build platform is solid, so you are going to do the scraping and also the adhesive forces, so you're going to have the thicker supports like I showed you on the PowerPoint. So those are a few of the main differences, but we have optimized it for a few NextDent resins. So if you're just looking to make a surgical guide every week, it's still a decent option. Let's see, it takes surgical guide, ortho rigid, which is the bite splints, and then models. Those are the three that we've optimized it for. Anything else?
All right. I think that's it for questions. So thank you very much, Adrian. That was an excellent presentation. Lucas, thanks for helping us out earlier in the during the session. And I think we got one last minute question here. Does it print a smooth or more pixelated? And I think this is referring to the entry level, the Form Pro.
The Fab Pro is going to have more build lines, but it's still one of the better printers on the market. So compared to the NextDent printer, it's not going to be as smooth. It will look like a printed object, but it's not going to be as bad as the one I showed you. If you want to benchmark, mark down my email and I'll send you something so you can compare the two if you'd like. I'll send you one of each and you can take a look at it.
All right. I think that concludes our session. Again, thank you very much. Please keep an eye on exocad.com/webinars. You'll see a number of previously recorded sessions there that go into very specific indications. We have more in the queue that we'll be offering here in the coming weeks. I think that this will be an ongoing project for us. While everyone was at home, I think some labs are starting to reopen, so we are going to space out our sessions, but I think they were well received by our audience, so it will be an ongoing project as we move forward. And Adrian, do you guys have any location where you publish your webinars or any additional resources for you? Oh, you might be muted.
You can find it on the NextDent page. And we will post it. We'll post it on Facebook and on our nextdent.com webinars page.
All right. Thank you very much, everyone.
Thanks for having me. Thanks for attending.